Hello friends, in this video we are going to see the working of exponential sweep circuit. This is a simple exponential sweep circuit which is used to generate voltage sweep waveform. When we supply a voltage of V, the capacitor will start charging if the switch is open. The capacitor charging depends upon the switch open and close. If you see that if the switch is closed, the output voltage across the capacitor is 0. That is equivalent to we are taking the output voltage parallel to a short circuit. If the switch is open, the capacitor will start charging. If we control the charging of the capacitor, we will able to get a linear voltage. So, when we see that the capacitor charging will be exponential in nature, if we close the switch in a time duration of sweep time, we will get a linear voltage. If the switch is open, the capacitor can charge to a maximum of supply voltage V. The output voltage of this circuit is given by V into 1 minus e power minus t by RC. This is obtained by considering a low-pass RC circuit by giving step signal as input. Here we are removing the switch. Without switch, what is the output for this circuit we are going to see. So when a step signal is applied, the supply voltage is equivalent to a step signal. So when we apply step signal, the output voltage will be an exponentially increasing signal, and after a time duration, the capacitor will charge to a maximum of the applied voltage. So the derivation for this output voltage, you can refer the YouTube video low pass RC circuit step signal as input. So in this, if we see here, this is the obtained signal. If we control the signal for a time duration t, then we will get a sweep signal. But in exponential sweep circuit, the obtained signal will not look similar to linear. So three types of error can occur in the generated voltage sweep waveform from exponential sweep circuit. First error is slope error. It is also called as sweep speed error. The second one is displacement error. Third is transmission error. What is slope error? Generally, in a voltage sweep waveform, the initial slope should be equal to final slope for the time duration of sweep time. If there is any change in the slope, that error is called as slope error. The rate of change of sweep voltage with respect to time should be constant. If there is any deviation from that, then that is called as slope error or sweep speed error. Mathematically, it is represented as difference in slope at the beginning and end of sweep divided by initial value of slope. So we know that slope means change in y-axis with respect to change in x-axis. So here y-axis is sweep voltage, x-axis is time. So change is given by dVs of t divided by dt. Initial time is taken as t is equal to 0 and the final end of the sweep, it is taken as t is equal to ts. So mathematically it is represented as dVs of t divided by dt at t is equal to 0 minus dVs of t divided by dt at t is equal to ts divided by initial slope. What is displacement error? Actually, we required a linear signal like this, which is represented as V dash S of t. But from exponential sweep circuit, the obtained signal is exponential in nature. If we consider the signal for a time duration of ts, it's look a small exponential in nature. So there is a small deviation from the required signal. This deviation is calculated as displacement error. So mathematically it is represented as difference in actual speed with respect to linear sweep that passes beginning and ending of actual sweep divided by amplitude of sweep at the end of sweep time. What is transmission error? Transmission error will occur in the sweep signal when we pass the generated signal through a high-pass RC network. If we pass the signal through any high-pass circuit, there will be a small deviation in the amplitude of the signal. So this deviation is calculated as transmission error. While generating the signal, the errors occurring are slope error and displacement error. While we transmit the signal through some circuit, the output of the signal will get some deviation. That error is called as transmission error. So mathematically it is given by difference in input and output voltage at T is equal to Ts. At T is equal to Ts, the voltage obtained voltage is Vs dash. When we pass the signal through a high pass network, the output voltage obtained at T is equal to Ts is Vs. So difference between this divided by input at the end of the sweep. So Vs dash minus V divided by Vs dash. So in exponential sweep circuit, we are going to calculate what is the error, slope error, displacement error and transmission error we are going to calculate. So we have already seen that from exponential sweep circuit, the generated voltage is V into 1 minus e power minus t by RC. By using binomial series, we can write the expression like this. And the sweep signal at T is equal to Ts. It is given by capital Vs. In the derivation, we will be using small Vs of T as well as capital Vs. We should be able to differentiate these two elements. Small Vs of T is the generated signal and capital Vs is the generated signal at T is equal to Ts. But the ideal sweep signal we have to be generated as Vs dash of T. It is given by Vt by Rc, where V by Rc is the slope of the signal. And the ideal sweep signal at T is equal to Ts is given by Vs dash. It is Vts by Rc. We will see slope error calculation for an exponential sweep circuit. So from exponential sweep circuit, the generated signal is Vs of t, which is equal to V into 1 minus e power minus t by Rc. Here we are considering that the signal to be linear, t by Rc should be very less than 1. If t by Rc is very less than 1, t is very less than Rc. Then we can apply binomial series e power minus x expression. If we apply binomial series expression for e power minus t by Rc, we will get a mathematical equation like this. This we are neglecting the higher order terms. We are considering only till second order terms. So the signal is Vs of t is equal to V into t by Rc minus t by Rc the whole square divided by 2 factorial. We already know that slope error is the difference between initial slope and final slope at t is equal to Ts. So to determine the slope, change in y with respect to change in x-axis is considered. So dVs of t divided by dt is given by V into 1 by Rc minus t by Rc the whole square. If we consider this change at t is equal to 0, the obtained signal is V by Rc. If we consider the end slope, that is at t is equal to Ts, then it is given by V into 1 by Rc minus Ts by Rc the whole square. The slope error can be calculated as when we substitute all this obtained values in this equation, we will get Ts by Rc. This derivation is very simple. You have to just substitute the values and check whether you are getting Ts by Rc. If you find any difficult in this, you can refer this slide. The whole derivation is given. Then we will see about displacement error. Displacement error, as already told, any deviation from the linearity is calculated as displacement error. The actual linear signal is Vs dash of t, but from exponential sweep circuit, the generated signal is Vs of t. So the starting and ending point is same, but there is a deviation. So this is calculated as Vs is equal to, here at t is equal to Ts, Vs of t is equal to Vs dash of t. So it is taken as Vts by Rc. In this, we are assuming that the maximum deviation is happening at Ts by t. So when we consider the maximum deviation, Vs dash of t minus Vs of t at t is equal to Ts by 2 divided by Vs. When we substitute all these values, when we equate it, this is the modulus 1. So maximum deviation we are taking. When we apply modulus, this minus will become plus. Substitute the value. The expression we will get for displacement error is Ts divided by 8Rc. If you find it difficult, you can refer this. And when we transmit the signal, generated exponential sweep signal through a high-pass network, there will be a transmission error. The transmission error is, there is a deviation in the amplitude of the signal. This difference is called as transmission error. Deviation in the input versus output voltage is taken. So V dash of S minus Vs divided by V dash of S. So substitute all the expressions. The answer we will get is Ts divided by 2Rc. The derivation for the transmission error is noted here. Then we are going to see the relation between slope error, displacement error and transmission error. Slope error is given by Ts by Rc, displacement error is Ts divided by 8Rc, transmission error is Ts divided by 2Rc. Out of these three errors, displacement error is less compared to transmission error and slope error. So with respect to displacement error, we are writing what is slope error and transmission error. So ED is equal to ES by 8, which is equal to ET by 4. Thank you.